The last section of CCNA Labs is about IPv6, and IPv6 is not the future. IPv6 is now, because most of US governmental sections are using IPv6, and it's mandatory since 2003. And now internet is using IPv6 as well, so you should know about configuring IPv6 on different parts of your network. Now I'm going to start by allocating, automatic IPv6 addressing to my router's interfaces. So I go to configuration mode first, and now that I'm in configuration mode, the first command that I need to enable is enabling IPv6 unicast routing. And by default, this is not enabled on switches or on routers. If you are working on switches, you have to enable it using IPv6 unicast routing distributed command. So here I'm in a router, I'm on a router, so I'm using unicast routing command and hit enter. And as a best practice, you should enable IPv6 ceph as well. So I do this always whenever I'm trying to, enable the IPv6. Now that I have enabled IPv6 globally, let's take a look at the IPv6 configuration on my interfaces first and then go to configure them. So show IPv6 interface brief will tell me the IP addresses assigned to my interfaces and different IPs. So I do not have anything here, and you can see that there is even no IPv6, link local IPv6 addresses here. That means none of these interfaces have IPv6 enabled on them. So first of all, I want to go to interface, for example, fast00, and the only command that I want to add here is this IPv6 enable. And whenever you do this, if you try to check the IPv6 interfaces addresses, you can see that there is a link local IPv6 address that is beginning with FE80 configured on this interface. And the second part, the second 64 bits, is compiled from the MAC address of your computer, your interface, plus the 16-bit FFFE in between them. And there's a little algorithm to, change the MAC address to this second part. And I'm not going to talk about this because you are going to know this in CCNP level labs. And you should know that this part of address is derived from your MAC address. So if you want to see what your MAC address is, just type in show interface and, for example, fast00, and I'm going to use a modifier to include just the line that contains the BIA world. And you can see that C001 is a little changed form of C201, and the last part 0000 is this. And if I change my MAC address, you can see that this address is gonna change. The BIA is the burnt-in address and it is not changing. But the MAC address that is assigned here, and by default it is the same as the BIA, is gonna change. Using the MAC address command, you can change this. For example, I'm going to make this the AAAA, and all 48 bits are gonna be A. So I hit enter, and now again I check the MAC address, IPv6 address, and you can see that it is changed because I have changed my MAC addresses here. So you can of course assign a static link local IPv6 address to your interface using the IPv6 address command, and I'm going to do this on my frame relay interfaces since I need to do that on GNS3 specifically, not on all, of course, routers or switches, but I'm going to do this as a best practice. So the first command is IPv6 enable, and it is going to add an IPv6 link local address to your interface. You should know that interfaces connect to each other using this link local IPv6 addresses, and some routing protocols such as OSPF use these link local IPv6 address to create neighborship in OSPF v3, for example. So I'm going to add some other address to this interface. So to do this, I add this command, IPv6 address. And now I can add an IPv6 address to this. So I'm going to add a global IPv6 address that begins, for example, with 2001. And now I'm going to add a subnet modifier here, for example, 12, to show that this is the section between router 1 and 2. And now I add a double colon to say that every other bit is going to be 0 until the end, that the last bit is going to be 1. So I have this address, 2001, 12, and double colon 1. And now I should add a slash here. And next I should add, for example, a 64-bit here to show that this is a 64-bit prefix IP address. So I hit enter, and now I have an IPv6 address on this interface that is global. So I copy this line of address. I'm going to add this to router 2 and check the connectivity here. So I go to enable mode, go to configuration mode, and the first thing that I want to do is this, IPv6 unicast address routing. And next, IPv6 CEF is best practice to do here. So I go to interface fast 00, and whenever you start adding an IPv6 address, this means that you are enabling IPv6 on this interface. So you do not have to enter IPv6 enable command here. And I paste this here, I go to change the last part of this address, and now that this is enabled, you can see that I have, to show IPv6 interface brief, I have a link local address as well. This is created by default because now that I have added an IPv6 address, the IPv6 is enabled on this interface. So if I try to ping this, to ping, and you should use IPv6 ping, but iOS is smart enough to understand that you are using an IPv6 address, so it uses IPv6 ping by default. So I'm going to ping 2001 12 1, that is router 1, and you can see that this is successful. Now the mechanism is a little bit different from IPv4. In IPv4 you had ARP messages. Here you do not have ARP messages, you have some kind of network discovery messages that I'm going to talk about in CCNA Labs. Now I have enabled this, and I'm going to enable IPv6 on other interfaces. So to do this, I have some other methods. Let's go back to router 1 and go to interface fast00 and fast01 and see what other methods are available here. I can add IPv6 address and just give the prefix to this interface. For example, 2001 double colon, a colon, and next the network ID is 13. So I add a double colon here, and add a slash, and no, not a slash, yes, add a slash and add 64 here. And this means that I'm not going to, show the second part of this address. I'm just telling that the first part of this address is 64-bit prefix, and now the second part is gonna be there using EUI64 algorithm. And this uses the same algorithm as the one that we saw in, link local IPv6 addresses. And I can show this to you. Do show IPv6 interface brief tells me about the addresses that is generated automatically using this prefix, and you can see that the second part is exactly the same as the second part of the link local IPv6 addresses that is there. So we have several options to add IPv6 addresses, and of course we can use auto configure using this. Suppose that I am having this prefix here on router 1, or even I have added static IPv6 address. For example, I have added 2001 13.1 to this IP to this interface. So let's do this. No IPv6 address here, and again I'm going to use 1 as this part and removing the no command here. Now, whenever you do this, this interface will start to, will start to use this prefix. And if I want to advertise this prefix, I have one piece of command to do this. Let's go to router 3 and go to configuration mode and enable IPv6 here first. And on interface fast 0.1 that is connected to router 1, I'm just using this command, IPv6 address, and to use this, I'm going to use autoconfig mode. So let's see what the IPv6 address is going to be here. So IPv6 interface brief, and you can see that I have used the prefix that is advertised by router 1. And without any command, I'm doing this because this command is working by default. This command is this IPv6 NRA ND or NDRA. Let's check it. Yes, IPv6 ND, that is for network discovery, and RA, that is for router advertisement. And this piece of command is working by default. And if you try to add some details to this, you can add interval or lifetime or anything else, or you can suppress this if you do not want router advertisement work by default. And because this is the default command that is working on every interface, the next interface neighboring this interface will receive the prefix and will auto-configure itself using the prefix that is advertised to it. So using the autoconfig, I'm receiving the prefix from the neighboring interface and I'm configuring this on my own. Okay, let's have this here, and I'm going to talk about configuring IPv6 on here on frame relay interfaces next.